Okay. So, in signal system, it's a complete mind map for the whole syllabus. So, in the last lecture, we have discussed about some signals. So, it's a quick recap. We did this definition. So, in definition, what we can say that signal is a way to convey the information of any physical phenomena is happening in this environment. And we can write it in a mathematical form, that is xt or xn, where xt represents the continuous time signal and xn is representing the discrete time signal. So, for example, uh, biosignals, communication signals, and some control signals. These are some examples of signals. If we talk about uh, how we can reduce or how can we uh, generate these signals, simulate these signals, we can use the MATLAB or Python. So in that, if we write in MATLAB window, x is equal to sine 2 pi f into t, and we have defined this t a time vector starting from 0 and full colon, then there is this middle part is representing the step to take to reach up to last final value, that is 1. Until then we continue with this. I hope definition about signal is uh, okay. Now we move towards the next topic, signal classification. So in exam, you can have one question from this, that is classify the signals. So for that, we can classify the signals by the six classification method. One is by continuity, by value type, by nature, by periodicity, by energy and power, and by symmetry. So let's start with by continuity. What we understand about this continuity means, as we already discussed, that the signal can be of two types or classified in two types or based on continuity. One is continuous time signal, another one is discrete time signal. So if we move forward, for continuous time signal like this, for example, audio signal, ECG signal, EEG, and if we make some temperature measurements throughout the year or throughout the day, then that particular period of time against the range of temperature will be a continuous time signal example. So in MATLAB, again, if we want to plot this continuous time signal, we can use this another method of generating the time vector, and that function is t is equal to line space, and this first one is for initial point and last one is for last point or end point, and then this 2 is the maximum gap between these two numbers, starting and ending numbers. So this will be also generating the same kind of thing as we did in the this one, where we have stated that starting from 0 ending with 1, and the time step is 0.001. Instead of writing this way, we can write and use the line space function. And after that, we have again a simple sine wave generated by this equation, which is x is equal to a star means multiplication, a multiply by sine bracket and then 2 plus 1 this star again is multiplication. Pi is the defined value. You don't need to write pi separately because it is inbuilt parameter, and then f and t. So it will give you the sine wave, that is a continuous time signal if we want to simulate, right? And if we talk about the in real sense, the ECG, EEG, audio signals, and your electricity coming at your home from generation to transmission to your system or your at your home, that kind of signal is also a sine wave in nature. So uh, for real world, analog sensors are almostly, or we can say that 100% develop the sense of the physical phenomena into a electrical signal or a continuous signal, or which we can say that a analog signal. That means analog sensor is required to produce analog electrical sensor or electrical signals, right? So in the next way, we can describe the second one, discrete time signal. Here, all n value is denoted by integer. So digital audio signals, sampled signals are the example of discrete time signal. For producing so for discrete time signal, we will take 10 samples from 0 to 10, and x will be a 2 pi sine 2 pi f into n by fs. What this fs is the sampling frequency. So then we can use the function stems in MATLAB to analyze this wave in a discrete way. So for discrete signals, we require a processor which is dedicated signals, and those processor are known as digital signal processor, right? Minus 3, and observe that in an equation we get this mark, then this will be representing n is equal to 0 starts from this value. So at n value is when n is 0, the amplitude of this will be 1. So we'll mark it like 1 unit and indicating like this. And from this 0 towards right hand side, all the values are incrementing like 1, 2, 3, 4 for the value of n. And then this 2 will be at in n value when n is 1. So at 1, this will be a 2 times, double the unit this. So this is representing 2, this is representing 1, and next will be 2. At position 2, the value of n, the value is 0, right? And at 3, this is the value of n. At this point, at here, we have the value minus 3. That means we have to mark it like downward side, and this will be your minus 3 on y-axis. This is positive y-axis and this is negative y-axis. So this kind of scenario tells about your discrete time signal. But for analog signal, right? So this is 0 and this is 1, and it continues from this time interval to this. Let it be 1 second. So for next 1 second, it is not on the y-axis. That means the value is 0. This is off state, and this will be treated as on state, and it continues in this fashion, right? So in discrete time signal, we can have any value -3, +2, 1, 0 on this side, or as well as in at this side also. But in the digital type of, right, if this pulse is like this, 1, then 1, then 1, then 1, let it be 0, let it be -1, let it be 1 and 2 and 3 and so on. At every point of n, if we have same value, 1 here, one strength amplitude here on y-axis, here we also have one, where we also have one, here we also one, the discrete signal, but it is pointing to the two states. At point n value n -1, the value is 1. Otherwise, from 0 -1 to 0, the value is 0. So it is also representing the two states on and off, but this kind of signal is known as impulse signal. Impulse signal, right? And why impulse? Because only at what we can have now, the next one is the classification by the nature. So on the basis of nature, we have two type of signal. One is deterministic signal, one is random signal. Let's no uncertainty will be there, fully defined, like sinusoidal wave or like thermal noise, EEG. There are very expression. Is it clear? अगर हम कोई मैथमेटिकली इक्वेशन लिख सकते हैं प्लस उसका sinusoidal wave, right? Then that signal is termed as deterministic signal. And if the signal is random, like noise or EEG signal, signal detection in noise means mixed way, the signal is hidden inside the noise, then that type of signal is known as random signal. We can't determine it and we can't specifically write the particular equation for that. So by this, next type of classification can be with the help of periodicity. We can have a periodic signal that is known by its non-repeating nature. कभी भी कुछ भी abrupt changes आ सकते हैं and they are not defined, like step and impulse exponential. These are some examples of aperiodic signal, right? And we have talked about this impulse. What impulse look like this? This is an example of impulse signal. So this comes under aperiodic nature or nature type of that signal. What about periodic signal? Periodic signal will be having some certain patterns and it repeats itself after a certain interval of time, like square wave, triangular wave, sawtooth wave, sine wave. These are the example of periodic signal, right? By the means of energy and power, we can separate it out or classify these signals in two frame. One is energy signal, one is power signal. For energy signal, we can have the fundamentals like it has finite energy and zero average power. Example, impulse functions or signals and decaying exponential signals are treated as energy signal, and transient signals are also termed as energy signal, right? So we have mathematical equations also to find out whether this signal is carrying some energy. If it carries some energy, then it will be an energy signal. And in this box, you can also observe that E is not infinite, but it will be limited or in the range below than infinite. But the power represented by letter P should be equal to zero, right? And for power signal, similar way, power should be not greater than this infinite, but it will limit in the range below than infinity. Then energy should be infinite. Whether in energy signal, this power should be zero, but in this case, power should be less than infinite, but the energy is infinite. If this kind of value we get after solving that equation, which generally used for the calculation of energy signal and power signal, then we can have this example like continuous waveforms. Continuous waveform are generally treated as power signal, like periodic signal or sinusoidal signals. So by the last symmetry, we can have two types of signal, even signal and odd signal. For even signal, like cos wave and Gaussian signals, are treated as even signal, and what it says that if xt, if there is any signal and we put x minus t, then both this wave are having the same shape, then that signal is known as even signal. For example, cos wave, if we put t here under this cos, or if we put minus t under this cos function, then it will not change any sign outer this cos, right? Because of this, there is no change in the wave shape of the cos wave. So that's why it's an even signal, right? So for odd signal, if we have xt and if we put x minus t in it, and it gives you this minus of xt. So that type of signal is known as uh, odd signal. And if we talk about the property, the if we take Fourier transform of that, it will generate a real component of that signal. And if we take uh, Fourier transform of a odd signal, then we lend it to the imaginary part to be computed from that odd signal part, right? So by this, we have covered the signal classification. And for a quick recap, we can say that on the basis of continuity, we have discrete signal and continuous time signal, right? On the basis of type of value it contains, we can have analog signal and we can have digital signal. On the basis of nature, deterministic and random signal. On the basis of periodicity, we have periodic signals and aperiodic signal. And on the basis of energy and power, we have two, energy signal and power signal. Some characteristics are here. And on the basis of symmetry, we can have even signal and odd signal. So today we have covered these classification of signal on the basis of these six values or 6 parameters, right? I will share this to you, no problem in that.